In this video, I will discuss the expression that allows us to calculate the magnitude of the gravitational force that the Earth exerts on an object when that object is close to the surface of the Earth. So the type of phenomena that I'm referring to now are you have the Earth. So this is the planet Earth, and you have an object that is close to that is fairly close to the surface of the Earth. Now, the magnitude of the gravitational force the Earth exerts on the object is the constant g, the mass of the Earth, the mass of the object, divided by their distance squared. Now, we have the numbers for the constant g, 6.7 times 10 to minus 11 meters. We know that the mass of the Earth is roughly 6 times 10 to the 24 kilograms. And we know that the radius of the Earth is approximately 6.4 times 10 to the 6 meters. Now, I will restrict myself in discussing problems where the object is not far away from the surface of the Earth, so it is very close to the ground. In that case, the distance between the two objects, so now I'm referring to this quantity, in that case, this quantity is not changing by much, whether you are on the ground or whether you're 5 meters from the ground or 10 meters from the ground or 100 meters from the ground. It does not change much the distance between the center of the Earth and where that object is. So this distance remains roughly constant if you are close to the surface. Now, I can estimate, I can approximate this distance in the following way. I can say that the magnitude of the vector r from the Earth on the object is approximately equal to the radius of the Earth. Is it always equal to that? Well, it is always equal to that only when you're on the surface, only when you're on the ground. But the important thing is that even if you're 5 meters away from the ground, it does not change really the distance from the center to where you are. The radius of the Earth is 6.4 times 10 to the 6th meters. Whether you add 50 meters or 100 meters does not really alter significantly this distance. So what I will do using this approximation, I will say, well, in that case, the magnitude of the gravitational force from the Earth on the object is approximately equal to the constant g times the mass of the Earth times the mass of the object, and then this is divided by roughly the radius of the Earth squared. Now, for problems where you are close to the surface of the Earth all the time, this quantity remains constant. You have g, the mass of the Earth, over the radius of the Earth squared. Now, this is what we call the constant g, lowercase g, and this is how we define this number. G, the mass of the Earth, over the radius of the Earth squared. Now, if you plug in these numbers for Earth, you will find this to be roughly 9.8 newtons per kilograms. So then this expression becomes the magnitude, so using, if I combine these, the magnitude of the gravitational force from the Earth on the object, this becomes g times the mass of the object. And this is a very useful expression. It is very useful to remember that if you're looking for the magnitude of the gravitational force that the Earth exerts on an object near the surface of the Earth, you can just multiply its mass in kilograms with 9.8. This will give you the magnitude of the force in newtons. Now, I defined this constant g for the Earth, but you can do the same thing for any other planet. You can, so long as you include the mass of that planet and the radius of that planet, you can calculate using this expression the constant g for that particular planet.